So welcome to National 4, National 5 chemistry lesson. We're still on Unit 1 looking at formula and calculations, and today's lesson is focused on calculations based on equations, specifically looking at moles and mass. So our aim for this lesson is to be able to use balanced chemical equations and gram formula mass to calculate the mass of a reactant or product whenever we are told information about another reactant or product. So the starting point for this is needing balanced equations. A balanced equation tells us the number of moles of each reactant and product for a given reaction. So for example, 2 calcium plus oxygen goes to 2 calcium oxide. That tells us that 2 moles of calcium react with 1 mole of oxygen to make 2 moles of calcium oxide. So the numbers written in front of the chemicals tell us the number of moles of that chemical that should form. And we call that the mole ratio or the molar ratio. So for this reaction, 2 calcium plus 1 oxygen going to 2 calcium oxide, the mole ratio is 2 moles to 1 mole to 2 moles of product. So as I said, that's called the mole ratio, sometimes called the molar ratio, and if you're wanting to be as fancy as possible, you can call it the stoichiometry. Now, if we use the mole ratio and the gram formula mass, we are able to calculate the mass of any reactant or product for a chemical reaction. So we've got an example, and we're going to talk through 2 different methods for doing these calculations. And we'll do 2 examples using both methods. Your choice is obviously to pick the method that you find the most efficient or the one that makes most sense to you. You calculate the mass of magnesium oxide which is produced whenever 6 grams of magnesium burns in oxygen. So we have got a balanced equation, 2 magnesium plus oxygen goes to 2 magnesium oxide. We have been told the mass of magnesium that is burning. And we want to know how much magnesium oxide is going to form. So we've got 4 steps. Now this is method 1. Our 4 steps, the first one is to balance the chemical equation, and often this has already been done for you. So 2 Mg plus O2 goes to 2 MgO. That's already balanced. The next step is to identify the chemicals that the question is asking us about and to write out the mole ratio. So we are looking at magnesium and magnesium oxide. We've been told that we have 6 grams of magnesium, and we were wanting to work out how much mass of magnesium oxide were being produced. The mole ratio, just looking at these 2 chemicals, is 2 moles going to 2 moles, and we can simplify that to the same as 1 mole going to 1 mole. So the next thing we do is we convert our number of moles in the mole ratio to masses by multiplying each one by the gram formula mass. So we're going to multiply 1 mole of magnesium by the gram formula mass of magnesium, and we're going to multiply the 1 mole of magnesium oxide by the gram formula mass of magnesium oxide. So that tells us that 24.5 grams of magnesium should give us 40.5 grams of magnesium oxide. Now what we're going to do is we're going to use proportion. So if 24.5 grams of magnesium give us 40.5 grams, 1 gram of magnesium will give us 40.5 divided by 24.5 grams of magnesium oxide. We have 6 grams, so we multiply that value by 6. 40.5 divided by 24.5 multiplied by 6, and that gives us 9.9 grams. So we've now been able to say that if we use 6 grams of magnesium, we should be producing 9.9 grams of magnesium oxide. Now, an alternative method for doing this question has us calculate the number of moles. This method is a bit longer, but this method can be used to lots of different types of questions. And this alternative method is the method that you would use for doing questions in higher chemistry. So it's up to you if you want to learn this method as well as the first method. But in this one, the steps are: do the balanced equation unless it's already a given, so there's no change there. The second step is to calculate the moles of your reactant or product. Then use proportion and the molar ratio to work out how many moles of your product you're going to form, and then turn the moles into a mass. So we start with our balanced equation, and this next thing we need to do is work out the moles of our reactant. Now we've been told that the mass of magnesium is 6 grams. We've been told that the gram formula mass is 24.5 grams. We can work that out. We can use the equation N equals M divided by GFM to work out that we have 6 divided by 24.5 moles, which is 0.245 moles. Now we look at the mole ratio. 2 moles goes to 2 moles, so 1 mole goes to 1 mole. We have 0.25 moles, so that means we're going to make 0.25 moles of our product. We've got the number of moles. If we multiply our number of moles by the GFM of magnesium oxide, that will give us the mass. So the moles of magnesium oxide is 0.245. The gram formula mass is 40.5. Mass is N multiplied by GFM, which gives us 9.9 grams. So we get exactly the same answer. You're actually doing the same calculations, you're just doing them in a different order. So it's up to you whether or not you want to use your proportion step with moles, or you're wanting to use the proportion step with mass. And it's up to you. Again, all I will stress is that this second method does take a little bit longer to do, but this method can be used in lots of different situations. Method 1 is quicker and can only be used for situations where you're dealing with mass. So we've got a second example. Calculate the mass of iron produced from 2 grams of iron oxide in this reaction. So we're going to look at method 1 first. So method 1, we've got a balanced equation. Well, that's what we have. Step 2 is identify the chemicals that we're working with and look at the mole ratio. Well, we're working with iron. That's what we've been asked to work out. And we've also been asked to work out, we've been given iron oxide and told that we've got 2 grams of it. Now the mole ratio is 1 mole going to 2 moles. Now the next step is to multiply the number of moles by the gram formula mass to tell us what the mass ratio is. So if we multiply 1 by the gram formula mass of iron oxide and 2 by the gram formula mass of iron, we get that 160 grams should give us 112 grams of iron. And then we use proportion. If 160 grams should give us 112 grams, 2 grams should give us 112 divided by 160 multiplied by 2, which is 1.4 grams of iron. Using method 2, again, first step is the balanced equation, which we have. Second step is to identify what it is that we need to work with and to work out moles. So we turn mass into moles. So the mass of iron oxide is 2 grams. The gram formula mass of iron oxide is 160. N equals M divided by GFM, which is 2 divided by 160, which is 0.0125 moles. We use proportion and the mole ratio. So 1 mole goes to 2 moles. So 0.0125 moles goes to 0.025 moles. Now we turn our moles into a mass. So the number of moles of iron is 0.025. The gram formula mass of iron is 56. And what we do is we do a multiplication. Mass equals N times GFM, which is 0.025 multiplied by 56, which is 1.4 grams. So you get the exact same answer. So it is up to you which one of these methods makes most sense to you and use it. As your teachers, we are able to mark both methods and understand both methods. There are alternative ways in which you can do the question, and if you come up with your own method, you can use that, but it is really important that you show all of your working out. So the reason why it's important that you show all your working out is that questions like this, if they're in an exam, are worth 3 marks. And I'll let you know what you need to do in order to get all the different marks. So one of those marks is for writing out the mole ratio for the 2 chemicals that you're asked about. Another mark is for getting the right answer, and the third mark is for your calculations, for showing them. So either using your proportion by mass or by calculating out your moles. But always you need to write out the mole ratio. If you write that out, you'll get a mark. Even if you cannot remember how to do the rest of the question, there's 1 mark always available for writing out the mole ratio. So here's an example on the board, on the screen. If you pause the video and have a go at trying to work that out. So hopefully you've had a go at this, and you should have found that the amount of carbon dioxide produced is 0.44 grams. The mole ratio of calcium carbonate to carbon dioxide is 1 to 1. 1 mole of calcium carbonate to 1 mole of carbon dioxide. The gram formula mass of calcium carbonate is 100. The gram formula mass of carbon dioxide is 44. And using all that information, you should have found out that 0.44 grams of carbon dioxide is produced. To finish off, we have 3 questions for you to try. You will need the data booklet in order to do these questions. So if you don't have access to the data booklet, unfortunately that's the end of this lesson for you. If you do have the data booklet, pause this video, have a go at the questions, and then return to the video and I will give you the answers. So for those of you who have had a go at those questions, we'll go through each question. So question number 1, calculate the mass of hydrogen produced when 5 grams of calcium reacts with an excess of dilute sulfuric acid. So we're looking at calcium and hydrogen. The gram formula mass of calcium is 40. The gram formula mass of hydrogen is 2. And 5 grams of calcium should produce 0.25 grams of hydrogen. The mole ratio in that case is 1 to 1. For question 2, calculate the mass of carbon dioxide formed when 0.8 grams of methane is completely burnt. So we're dealing with methane, which is CH4, and carbon dioxide, CO2. The mole ratio is 1 to 1. The gram formula mass of methane is 16. The gram formula mass of carbon dioxide is 44. 0.8 grams of methane should give 2.2 grams of carbon dioxide. And the final question, calculate the mass of water produced by burning 10 grams of hydrogen. In this case, the mole ratio is 2 to 2, which we can simplify to 1 to 1. The gram formula mass of hydrogen is 2, the gram formula mass of water, H2O, is 18. If we use 10 grams of hydrogen, we would be producing 90 grams of water. So that concludes our use of equations and moles in order to predict or calculate the amount of product or the amount of reactant necessary for a reaction to happen. Next time we will look at moles and solutions.